Okay, I've left a copy of notes for these notes today, so if Mrs. Pruitt hasn't passed those out yet, you can pause the video while she passes them out, and then I can start. We're just going to go over your homework from yesterday tomorrow, and we'll go over both days' homework questions, because hopefully they won't be so many, and then go on from there. Today we're going to look at looking at a graph of a function and answer questions about it. There's a lot of pictures today, which is why I printed your notes out, but hopefully it won't be that bad to get through here. So the first one here says determine if the graph is a function. If it is, find the domain and the range, find the intercepts, and find any symmetry with the x-axis, the y-axis, or the origin. Remember that to be a function, it has to pass the vertical line test. So what's super great about these problems is if it's not a function, you don't have to do parts A, B, and C. You can just say no. But number one is a function because it does pass the vertical line test. So I'm going to say yes. And then for part A, it says find the domain and the range. So when they give you a graph, it's really nice because you can look at the domain. The domain is the x's. Notice on this one that these are dots here. They end. So we're going to say that the domain is from negative, well, I guess I should say domain here. Domain is from bracket negative pi to pi. And the range is the y values, which means on this one it looks to me like it goes from -1 to 1. I know it's kind of probably hard to read on the copy. Part B says find the intercepts. The intercepts are where it crosses the x or y axis. Make sure you tell me if it's the x or the y intercept. So on part B, for the x-intercept, it crosses at x equals negative pi halves and x equals pi halves, which you could also write as negative pi halves 0 or pi halves 0. And the y-intercept is where does it cross the y-axis? And it looks to me right here, it crosses the y-axis at 1. So that would be y equals 1 or the point 0, 1. For those of you that took pre-calculus last year, maybe this looks like a trig function graph that maybe you recognize. And part C says find any symmetry with the x-axis, the y-axis, or the origin. Remember, that means if you could like flip it over those lines, would they be the same? And so much easier than with an equation. For part C on number 1, I don't think it's the x-axis because it's not the same on both sides, but I do believe it's symmetrical with the y-axis because if I took this side here, I could flip it over and it would match up the other side. And the origin, remember, is like if I took it and flipped it over from like quadrant 1 to quadrant 3, which does not work on this one. So part C would just be the y-axis. Number 2, super great, is not a function because it fails the vertical line test, which means I don't have to do parts A, B, and C. What about number 3? I would say number 3 is a function. So let's start with part A, the domain and the range. Again, when they give you a graph, maybe it's a little bit easier to do. The domain of this is what x values are used. Well, unlike number 1, this graph has arrows going down, which means this graph's going to go on forever, which means every x value could be used. I can also tell you this looks like a quadratic to me, so the domain is going to be all real numbers. Squish that in there. But what about the range? Is the range of this going to be all real numbers? I think the answer is no. Oh, excuse me. Because it stops right here, right? It's going to go down forever, but the highest it's ever going to get is 5. So it's going to go down forever, which means it's going to go from negative infinity, but it's going to go all the way up to 5, and then it's going to stop. So I would say from negative infinity to 5. If you're a set notation kind of person, for the range there, you could say y such that y is less than or equal to 5. Okay? What else we got? Okay, look at this. Whew, there's a lot of stuff on this. I might have, did I give you the next page blank to do this on? Oh no, I didn't. Look at this graph. It says use the given graph of the function to answer parts A through N. Oh my gosh. That's like half the alphabet there. Mostly it's just trying to get you used to the notation here in math class. Know what it's asking. So a lot of these should not take you a lot of work to do. It's just answering the questions. So part A says find f of 0. What does that mean? That means when x is 0, right? 0 is in the x spot. What would you get for y? So you just look on the graph and say, oh, when x is 0, y is 3. Find f of negative 6. So that means when x is negative 6, what's the y value? So go over here where x is negative 6, and the y value is negative 3. So I feel like you could do part B now, find f of 6 and f of 11, right? It's just making you go through there and find those values. So we're just going to kind of jump around on these. Same thing on C. It says f of 3. Is f of 3 positive or negative? So it's not asking when y is 3. It's saying when x is 3, go up and find the value. Well, I don't know what it is, but I can see that it's above the x-axis, so I can see that it's positive. So again, you could do part D now. What about E? E says, for what values of x does f of x equal 0? So again, you got to think about what this is asking. F of x is the same as y, so this is kind of saying, where does y equal 0? So look on this graph and tell me, where does y equal 0? Well, it looks to me like y equals 0 right here, and right here. So for what values of x? At x equals negative 3, at x equals 6, and at x equals 10 would be the answer for part E. What about F? F says, for what values of x is f of x greater than 0? Again, remember that f of x is another word for y. So they're saying, where is y greater than 0? This is going to be a lot of answers. Don't just tell me the points up there. Because it's greater than 0 everywhere that it's above the x-axis, right? Those are all positive y values. So we should give like an interval here. At negative 3, is it greater than 0 at x equals negative 3? No, it's equal to 0. So I'm going to say parenthesis negative 3, and it is positive all the way until right here, right? So all the way till 6. And then it's also starting back at 10, but it doesn't go on forever. It stops at 11. So I'm going to say bracket 11 because 11 is included. Domain and range, those are just the x and the y values, which these are closed domain and range because it stops and starts. I'm not going to go through all these, but I can answer questions tomorrow if you have more questions. But x-intercepts and y-intercepts, think about x-intercepts are where it crosses the x-axis. Y-intercept is where it crosses the y-axis, or it's when the other one equals 0. What about K and L? K says, how often does the line y equal 1/2 intersect the graph? Where would the line y equals 1/2 be up here? Some of us got these confused on our test. Y equals 1/2 would be a horizontal line at 1/2. So what if you just drew that through there? How many times would the line y equals 1/2 intersect that graph? No work to show on that, right? I think the answer would be 1, 2, 3 times. I know that's a little off, but Same thing with L. It says, how often does a line x equals 5 intersect the graph? X equals 5. 1, 2, 3, 4, 5. Remember, x equals is a straight up and down line. So what's the answer to that one? 1. Only crosses one time. M and N, kind of different than E up there. M says, for what values of x does f of x equal 3? I guess it's kind of like that. We're just changing it to 3 now. So that's just asking you, where does y equal 3? For what points do we have a y value of 3? And it looks to me like there's 2 of them at x equals 0 and x equals 4. So these are not hard questions. They kind of look overwhelming because there's so many parts to them. But it's just looking at it and the notation that goes along with it. Okay? Hopefully not so bad to do. Is there more here? No. So what about if they don't give you a graph? What if they just give you an equation and ask you some of the same stuff? Sometimes it's a little bit trickier. So part of your homework, I give you a question like this, where I ask you to answer some stuff about the question. So given this function, which looks to me like is going to be a quadratic because it's x squared, it said, is the point 1, negative 2 on the graph of f? Well, there's no graph here, but remember that this is an x and this is a y. So it's like saying, when x equals 1, do I get a y value of negative 2? So let's see what happens. What happens when I plug 1 in there? I'm going to get 2 times 1 squared minus 1 minus 1. Looks to me like I'm going to get 2 minus 2, which is 0. Which means when x is 1, y is 0, not negative 2. So I would say the answer to that is no. Look at part B. Part B says, if x equals negative 2, what is f of x? What point is on the graph of f? So it's kind of just like A, just asking it a different way. If they ask you what is f of x when x is negative 2, they're just asking you to find f of negative 2. Make sure you use your calculator correctly if you're typing all this in your calculator. But that would be 4 times 2, which is 8. Minus negative 2 would be plus 2. 10 minus 1 would be 9. So the point would be, when x is negative 2, the y value is 9. Now what about part C, going the other way? It says, if f of x equals negative 1, what is x? What points are on the graph of f? So now notice they're giving you the y value. So instead of plugging negative 1 in for x, you're going to replace f of x with negative 1. Sorry, I just need to be able to see this. So you end up with this equation. Negative 1 equals 2x squared minus x minus 1. So I'm going to add 1 to both sides to get that equal to 0. And I'm going to get 2x squared minus x, because that's going to go to 0 also. Which means I think I could just factor an x out of this. And I get 2 answers. Notice they say points there. I get x equals 0. And 2x minus 1 equals 0. So at 2 different times, there's excuse me, a y value of negative 1. So the points would be the point 0, negative 1, and 1/2, negative 1. And that should make sense that it's a parabola, that the y value is going to repeat itself. It also asks for the domain. This is where you got to know the graph here, right? This is a quadratic. It's a parabola. What's the domain of every parabola? All real numbers. It also talks about intercepts. intercepts, you got to know how to find those not without a graph, like with just an equation. Remember, the intercept is when it crosses the axis, or it's when the other one is 0. So when it asks for the x-intercepts, it's just asking, what do you get when y is 0? So if I set this equation equal to 0, I got to solve that, and that's a quadratic. Which means, I don't know, what do we do here? Factor by grouping? So we multiply by -2, and we say what multiplies to give me -2, that subtracts to give me -1 in the middle. So I could make that minus 2x plus 1x minus 1. I could pull a 2x out and get x minus 1. Over here, I can take a 1 out and get x minus 1. So that factors into x minus 1 and 2x plus 1. So I get x equals 1 and x equals -1/2. X-intercepts of a quadratic a little bit harder to find. The y-intercept is my favorite point to find because the y-intercept means what do I get when x is 0? Right? Which if I make x equal to 0, I'm just going to get -1, which means it would cross the the y-axis at -1. You can write these as points or numbers like this. Like I just leave it like this, but that's really the point 0, -1. Whereas up here on the x-intercepts, that would be the point 1, 0 and -1/2, 0. Okay, so think about those when you're doing these problems today. Hopefully not so bad. I picked these because it just kind of makes you think a little bit. And I gave you one on your homework tonight. Like I forget which one this was, the cost of a building. This is like number 39, and I gave you number 40. I wish I was here so we could kind of discuss this. But it says match each of the following functions with the graph that best describes the situation. So I'm going to just kind of read through these and let you kind of think about them, and then we'll see if we can agree on this. It says the cost of building a house as a function of its square footage. So that means, you know, looking at that, to me, the cost is going to go up as the square footage goes up. The height of an egg dropped from a 300-foot building as a function of time. So if I'm at the top of a building and I drop an egg, it's going to just fall down, right? The height of a human as a function of time. So think about, you know, you're going to grow for a while, but then you're going to stop. The demand for Big Macs as a function of price. Well, we could argue that people always eat Big Macs or they never eat Big Macs, no matter what the price is. But think about supply and demand. If the price goes up, the demand's going to go down. So the demand's going to go down as the price goes up. And the height of a child on a swing as a function of time. So think about the height is going to go up and down, up and down, up and down. So doing some, I think we can like eliminate some. Like the height of a child on a swing as a function of time. Which one of those makes the most sense to you? I think it has to be E. E has to go with, sorry, I guess this is number 2 here. I think it's easier to call this one E. The height of a human as a function of time. You might want to say 3, but I think 1 is the best choice because you're going to grow. You grow pretty fast as a kid, but I haven't grown in a long time, right? My height's pretty much leveled off. So I would say that this is C. The demand for Big Macs as a function of price. To me, that's the only one that makes sense, that it's kind of like the demand's going to go down as the price goes up. So D, do you agree with that? Because over here would be like low price. so the demand's really high. But over here, as the price gets higher, the demand's going to get low, like not buying much of it. The cost of building a house as a function of its square footage. As the square footage goes up, the cost is going to go up. So that has to be 3, right? Which means the height of a dropped egg from a 300-foot building as a function of time. The height's definitely going down. I don't know, why is it curved like that? But I think that has to be the answer. Wish I was here so we could discuss this, like I said, but let's see. I'm checking my answers here because I'm doubting myself. Section 3.2.3.3. What section is this? Number 3.4.1.5.2. Yeah, okay, just checking. So we really have done examples like all the problems on your homework today. So try these. If for some reason you didn't finish yesterday's homework, you need to finish that. Tomorrow we're going to have a longer homework quiz because of both of these and do new notes tomorrow. So this is your homework, number 10, which is a long one. Kind of like the one that we did that was long. 12 through 24 multiples of 3. Most of those are like our first ones with the pictures where you're going to say, is it a function, domain and range, intercepts, and symmetry? And then 26 and 27, answer some questions about the problem. And then 40 is just like this last one that we did. So good amount of problems. Work on this, and we'll discuss questions that you have tomorrow.